Hello, I'm Steve Jones, and I'm going to talk to you a little about how transistors work. I'm not going to concentrate on the actual physical workings. I'm going to look at how they actually replaced something which we had in the old technology, which were valves. Valves were very large glass objects which got very hot. They were very expensive to make, and your telephone, if you use valves, would be fitted in a suitcase. So they're not very useful from that point of view. You need a huge battery, and you need a lot of energy. Transistors are based on two materials, one called silicon, the other germanium. Most of the technology nowadays uses silicon. Germanium is used for some only very specialist purposes. Silicon is the main basis of transistors. The first thing we have is what we call a silicon chip, or a slice of silicon crystal. The crystals of silicon are grown specially, and they're about so long, about 1 meter long, and in diameter 15 centimeters. They're round in section. These are cut into slices very specially, and these are called semiconductors. That is, they don't conduct electricity. As far as we're concerned, they hardly conduct electricity at all. What we do with this is we can create something that acts like a valve by various photographic techniques. We create what is basically a negative, as you would if you were taking a photograph. The old type of photograph, not digital photographs, of course. And on the surface of this, we can lay a pattern, and then the silicon is exposed to things like indium, germanium, arsenic. These are chemicals which are absorbed into the silicon. The effect of this is to change the way the silicon works, change how it conducts. So this part of it, doped, as we say, we use the word doping, we dope it with arsenic, and then it conducts electricity in a certain way. Once we've done this process several times, the final layer is a layer of aluminium and some gold connectors. So there are little gold wires which are then soldered to the surface of the silicon chip. When you see a silicon chip, when you see an integrated circuit, this is called an integrated circuit. When you see your integrated circuit, in fact, all you see is a plastic case with a lot of little legs, and the legs are the connectors. Inside is the silicon chip. It is tiny. It is just 1 millimeter square or 2 millimeters square. It is not a big thing. 2 millimeters by 2 millimeters. And on that can be as many as 1 million transistors. This is why everything can be made so small. Why in your watch, inside it is not a lot of wheels. It is a single silicon chip, a single program silicon chip, and a battery to operate it. So this now replaces our valve. Can you imagine how big the machine would be if we had 1 million glass valves, each this size, and replace that with just a single 2 millimeter by 2 millimeter silicon chip, and the display, in our case for the watch, or for any of the machines that we use. You'll find transistors in almost everything now that you can buy. In your washing machine, in your microwave. It's in your car. Your car talks to you nowadays through an integrated circuit made out of silicon chips on which there are transistors. And the transistor, remember, is the smallest unit replacing a valve. So this is how now transistors benefit us in making things smaller making things transportable, making things movable.